Bismillahirrahmanirrahim. Today lecture we discuss the eigenvalue and eigenvector of a matrix A. So in this lecture we discuss the different properties of eigenvalue and what is eigenvalue and its properties, and if we find the eigenvalue, then the next step is we will find the eigenvector. So first we discuss the eigenvalue, and secondly we discuss the eigenvector. So what is eigenvalue? First we write the eigen equation, and the eigen equation is first we write the eigen equation, and eigen equation is Ax is equal to lambda x, and A is our matrix, and x is the column matrix or solution vector, and lambda is the eigenvalue. So we write here x is a column vector or solution vector or a solution vector. Basically x contain the values of unknowns like x1, x2, x3 and so on, and lambda is the lambda is the eigenvalue. So if we find the lambda, then each lambda we have eigenvector, and this is the eigenvector. This column vector or solution vector is the eigenvector. So if we write this equation, ax minus lambda x is equal to 0, and we write this a minus lambda I x is equal to 0. So we have two possibilities here. If we put a minus lambda is equal to 0 or x is equal to 0. If we put x is equal to 0, this implies trivial solution. So we put here determinant of a minus lambda I is equal to 0. Solving this equation, we find the eigenvalues. Solving this equation, we get eigenvalues. Say lambda 1, lambda 2, lambda 3 and so on. So lambda 1, lambda 2, lambda 3 are different eigenvalues. Okay, so we write this vector A, we put this vector, this matrix A into this equation. So first we write A 1, 2, 2, 1, minus 2, minus 1, minus 1, 1 and 4, and minus lambda, and what is I is the identity matrix 1 0 0 0 1 0 0 0 1, and determinant of this is equal to 0. Okay, so this becomes 1 minus lambda 2 2 1 2 minus lambda minus 1 minus 1 1 and 4 minus lambda matrix of determinant is equal to 0. So we take the determinant of this matrix, and this become 1 minus lambda 2 2 1 2 minus lambda minus 1 minus 1 1 4 minus lambda is equal to 0. So this is determinant, and in here lambda is the eigenvalue, and so we expand this determinant by C1 or R1. So it's we expand by R1. So we write this 1 minus lambda, and this become 2 minus lambda minus 1, 1, 4 minus lambda. This is minus 2, and this become 1 minus 1 minus 1, 4 minus lambda, and plus 2, this become a 1, 2 minus lambda, a minus 1 and a 1, and this is equal to 0. So solving this determinant, we get 1 minus lambda, 2 minus lambda, 4 minus lambda, and plus 1, and minus 2, 4 minus lambda, minus minus plus again minus lambda, plus 2, a 1, a plus 2 minus lambda. This is equal to 0. So solving this equation, we get the values of lambda and simplify this. So how to simplify this? This is so simple. This is 1 minus lambda, and multiplying this, so this become 8 minus 2 lambda minus 2 lambda minus 4 lambda plus lambda square plus 1, and this is equal to minus 2, 4 minus 1, 3 minus lambda, and this is plus 2, and this is 3 minus lambda is equal to 0. So we see that these two terms are equal and opposite sign, 2, 3 minus lambda and plus 2 minus 3 lambda. So both terms are cancel out. No further simplification are required. So we solve this equation. So this is 1 minus lambda, and this become lambda square minus 6 lambda plus 9 is equal to 0. So we factorize this term, or we use the quadratic formula. So first we check the factor. So the factor of this is minus 3 lambda minus 3 lambda plus 9 is equal to 0. So I solve this, we get 1 minus lambda, take lambda common, lambda minus 3 lambda minus 3 equal to 0. So we solve this, and this become 1 minus lambda, lambda minus 3 is equal to 0. So lambda is equal to 1, 3, 3 and 3. So these are the eigenvalues. These are the eigenvalues, lambda 1, 3, 3 and 3. So in this way we calculate the eigenvalues. So this is the answer of first question, find eigenvalues. But we have different properties of eigenvalues, and I discuss here different properties of eigenvalue. So I discuss different properties of eigenvalue one by one. So the first property is any square matrix A and its transpose have the same eigenvalue. The first property is properties of eigenvalues. So this is very important. Properties of eigenvalue. This is very important. So the first property is any square matrix A, any square matrix A and its transpose have the same eigenvalues. So if we have matrix A, or we take its transpose matrix, then we have the same eigenvalues. So this is the first property, and the second property is sum of element of principal diagonals, sum of elements of principal diagonal is equal to trace of A. So in here we discuss the definition of trace of A. So trace of A is basically we add the diagonal element, principal diagonal element. So in this question, trace is this is the trace elements, and if we add these elements, then we get the trace of A. So trace of A in this example is 4 plus 2 plus 1, 4 plus 2 6 and 7. So trace of A of our problem is 1 plus 2 plus 4, and this is equal to 7. So the next property is very interesting property and very important property. The sum of the eigenvalues, the sum of the eigenvalues of a matrix A is equal to the trace of A, is equal to the trace of A. So in our problem, a trace is 7, and in this problem, eigenvalues is a 1, 3, 3. So 3 plus 3, 6 and 1, 7. So this is equal to 7, and trace of A is also 7. So using this property, we conclude that our eigenvalues are correct. If these properties are not hold, it's mean our eigenvalues are not correct, and we attempt some mistake in solving the eigen equation. So this property is very important, and the next property is also important. The product of the next property is the product of the eigenvalues of a matrix A is equal to the determinant of A. This property is very important. And this property says that the product of the eigenvalue of a matrix A. So a product of eigenvalues of A is 1, 3 and 3. This is equal to 9. So product of our problem, this is our problem, and this is our eigenvalues, and product of these three values is equal to 9. So we calculate the determinant of A, and if determinant of A is equal to 9, it means our eigenvalues are correct. If determinant of A is other than 9, it means our eigenvalues are not correct. So we find the determinant of A here, and determinant of A is equal to, and this is equal to 1, 2, 2, 1, 2, minus 1, minus 1, 1 and 4. So calculate the determinant of A. So by expand by R1, this is 1, and this is 2 minus 1, 1, 4 minus 2, and this is a 1 minus 1, 4 plus 2, and this is 1, 2 minus 1 and 1. So calculate this. So this is 1, 4 to the 8 plus 1 minus 2, 4 plus 1, 4 minus 1 plus 2, 2 plus 1 plus 2. So this is equal to 9 minus 2, 3 plus 2, 3. So these two are cancelled out. The answer is 9. So determinant of A is 9, and product of the eigenvalues is 9. So it's mean our eigenvalues are correct. So these two properties are very important properties, and these two properties ensure our eigenvalue is correct. So this is the complete description of eigenvalue. Now we calculate the eigenvector. So how to calculate the eigenvector? In here we have three eigenvalues, 1, 3, 3, 3, and two eigenvalues are repeated. So we take only two values, 1 and 3, because 3 is twice. So we take only one value, that is 3, and one value is 1. So we check the eigenvalue of these two values. So we have if we have two eigenvalues, it's mean we have two eigenvectors. Each eigenvalue corresponds to one eigenvector. So first we check the we come back to the equation. This equation ax is equal to lambda x. So we calculate the eigenvector from here. So again here ax minus lambda x is equal to 0. So we take ax minus lambda x is equal to 0. X is your eigenvector. So a minus lambda I x is equal to 0. So we first find the a minus lambda. So what is a? A is 1 to 2 and 1 to minus 1 and minus 1 4. So minus lambda is lambda 0 0 0 lambda 0 0 0 lambda. And what is x? X is the eigenvector, and that is equal to x1, x2, and x3. Because the column, if these two are multiply, so column of in this matrix is equal to rows of this eigenvector. So we take x1, x2, and x3. Solve this. So this become 1 minus lambda 2 1 2 minus lambda minus 1 1 and 4 minus lambda, and this is x1, x2, and x3 is equal to 0. So we solve this system. Basically this is ax is equal to 0. This is the homogeneous system. And we very well know that how to solve the homogeneous system, and in what condition the homogeneous solution is unique, infinite many solution, and no solution. So we solve this. If we take the value of lambda is equal to 1, first we check the lambda is equal to 1. So put here lambda is equal to 1. This become 0 2 2 1 2 minus 1 1 minus 1 minus 1 1 4. So this is equal to 0, because if we put x1, x2, x3 is equal to 0, so this becomes the trivial solution. But we are always interested in non-trivial solution. So reduce this into row echelon form by using the operator. So first we change the r1 2. So this become 1 1 minus 1, and this is 0 2 2, and this is minus 1 1 4. We this is pivot point 1, and in here we this 1 minus 1 replaced by 0. So by using the operator r3 plus r1, so 1 1 minus 1 0 2 2 minus 1 plus 1 0 1 plus 1 2 and 4 minus 1 is equal to 3. So we make the 1 here. So 1 by 2 are 2. So this become 1, 1 minus 1, 0, 1, 1 and 0, 2, 3. So we make the 0 here, convert into echelon form. So this operator is R3 minus 2 times R1 and this become 1, 1 minus 1, 0, 1, 1, 0, 2 minus 2, 0 and 3 minus 2, 1. I think this is enough. This is echelon form and this is enough to find the solution. So we write the equation or we convert this into reduced echelon form. We also have option to convert this it into a reduced echelon form. I think this is enough. So this become the I will write this equation into the system form. This become x1 plus x2 minus x3 is equal to 0. x2 plus x3 is equal to 0 and x3 is equal to 0. So x3 is equal to 0, then x2 is also x2 is 0, 1, 1. So in this we find the some mistake here. This is 4 minus 1 and this become 3. So this is 3 and after applying the these operator I have mistake just in here 1 and these all terms are 0. So correct the this term, this is 3 and this is 3 and this become 2 and in the last this become this and 1 1 this is 1 1. Okay, so please correct this system. Okay, so the our system become 1 1 1 and 0 1 1 and 0. So we write this into in the system form. This become x1 plus x2 plus x3 is equal to 0, x2 plus x3 is equal to 0 and this whole term or the whole row are 0. So x2 is equal to minus x3 and put x3 is equal to put x3 is equal to a. So x2 is equal to minus a, x3 is equal to a, x2 is equal to minus a and x1 is equal to 0. Put in here a and minus a, so x1 is equal to 0. So we write the this vector x1 x2 x3 is equal to what is x1? X1 is 0, x2 is minus a and x3 is equal to a. I will take the a common and this becomes 0 minus 1 and 1. So this is the eigenvector corresponding to the eigenvalue and eigenvalue is lambda is equal to 1. So I again repeat some mistake here. 4 minus 1 is equal to 3 and please correct the entries here and at the end this is the correct matrix. So now we calculate the eigenvector against lambda is equal to 3. Against lambda is equal to 3. So if lambda is equal to 3, so what is the eigenvector? So put here yes, put here lambda is equal to 3, put here 1 minus 3 minus 2, this is minus 2 2 2 1 2 minus 3 2 minus 3 is equal to minus 1 minus 1 minus 1 1 and 4 minus 3 is 1, 4 minus 3 is 1 and this is x1 x2 x3 is equal to 0 and this is ax is equal to 0. So we solve this system. This is a non-homogeneous system, so solve this matrix minus 2 2 2 1 minus 1 minus 1 minus 1 1 and 1. So uh, I want to make a 1 here, so minus 1 by 2 r1, so this become 1, and this is minus 1, this is minus 1, 1, minus 1, minus 1, minus 1, 1, and 1. So reduce this into echelon form, so r2 minus r1, so 1 minus 1 minus 1, 1 minus 1 0, minus 1 plus 1 0, minus 1 plus 1 0, and we again my 0 here, so the operator is r3 plus r1, so minus 1 plus 1 0, and minus 1 plus 1 0, and minus 1 plus 1 0. So in here so in here both rows are equal to 0, so x1 minus x2 minus x3 is equal to 0. So we have three unknowns and one equation, so we fix the two unknowns, so x3 is equal to a, and x2 is equal to b, so x1 minus b minus a is equal to 0, and x1 is equal to a plus b. So eigenvector is x1 x2 x3 is equal to, and this is equal to a plus b, and b and a. So if we write the linear combination of two matrix, so how to write this? Take a, and this is matrix, and write b, and this is matrix. So put 1 1 here, and this is b, so a 0, and this is b, so 1 here, and this is a, and 1 here, and this is b 0 here. So this is the linear combination 1 1 0 and 0 1 0. So a plus b, 0 plus b, a plus 0. So this is the this is the eigenvector against lambda is equal to 3. So this lecture is very important. Eigenvalue, how to calculate the eigenvalue, and how to calculate the eigenvector. So for more information and for more mathematical videos, stay tuned. Jazakallah, thanks. Jazakallah, thank you.